Imagine an explosion so powerful it could knock out satellites and disrupt power grids across entire continents. Welcome to the world of solar flares. These explosive storms on the sun are more common than you might think, and they have a direct impact on life here on Earth. Today, we'll explore how these massive bursts of energy form, what they do to our planet, and how scientists track them. Solar flares are sudden releases of magnetic energy that occur when the sun's magnetic field lines become twisted and unstable. These explosive events typically originate from sunspots, which are cooler, darker regions on the sun's surface. When magnetic field lines reconnect, they release tremendous amounts of energy in just minutes. The result is a brilliant flash of light and a stream of charged particles racing through space. To put this in perspective, a single large solar flare can release more energy than billions of hydrogen bombs. The sun's magnetic field is constantly changing, which is why solar flares are a natural and frequent occurrence, though their intensity varies dramatically. Scientists classify solar flares using a scale from A to X, with each letter representing a 10-fold increase in energy. M-class flares are medium-sized and can cause brief radio blackouts. X-class flares are the most powerful and can have significant effects on Earth's technology. The largest X-class flares can be more than 10,000 times more powerful than the smallest A-class events. The most powerful flare ever recorded was an X-28 event in 2003, which saturated measuring instruments. During solar maximum, we can see several flares per day, while solar minimum periods may have very few. When solar flare particles reach Earth, they create some of the most beautiful natural phenomena we know, the auroras. But the effects aren't always so beautiful. Solar flares can damage satellites, disrupting GPS navigation, communications, and weather forecasting. Large flares can induce electrical currents in power lines, potentially causing blackouts across vast regions. In 1989, a solar storm knocked out power to 6 million people in Quebec for 9 hours. Solar flares also disrupt radio communications, forcing airlines to reroute flights away from polar regions. Astronauts face increased radiation exposure and may need to take shelter during major solar events. Our increasingly connected world makes us more vulnerable to space weather than ever before. Fortunately, Earth's magnetic field protects us from the worst effects, but it's not a perfect shield. Scientists use a network of satellites and ground-based observatories to monitor the sun 24 hours a day. Satellites like SOHO and SDO can detect the early signs of flare activity. The Space Weather Prediction Center issues forecasts and warnings just like meteorologists do for Earth's weather. Ground-based solar telescopes provide detailed observations of sunspot development and magnetic field changes. Advanced computer models help predict when and where solar flares might occur, though perfect prediction remains challenging. When a major flare is detected, warnings can be issued within minutes. This gives satellite operators and power companies time to take protective measures. International cooperation ensures global coverage and rapid information sharing about solar threats. While we can see flares immediately, the particles that cause the most disruption take 1 to 3 days to reach Earth. As we approach the peak of the current solar cycle, solar flare activity is expected to increase. But thanks to improved monitoring and better technology design, we're more prepared than ever before. Scientists continue working to improve our understanding and prediction capabilities. Solar flares remind us that we live in a dynamic solar system, connected to our star in ways both beautiful and powerful. Understanding these explosive storms helps us protect our technology while appreciating the incredible forces that shape our cosmic neighborhood. Thanks for watching, and don't forget to subscribe for more fascinating science content.